About 2 days ago, we derived a formula to integrate sine nth power x dx. We derived a reduction formula. To derive that formula, we started labeling this given integral as I sub n. We showed that I sub n is equal to negative 1 over n sine raised to the n minus first power x times cosine x plus n minus 1 over n times I sub n minus 2. In fact, we discussed a complete example also using this formula. The example that we discussed was I sub 7, which was the integration of sine 7th power x dx. After solving that integral using this reduction formula, we figured that the final answer tends to be fairly long. However, during our last discussion, we indicated that about 350 years ago, this very same formula was used effectively by a British mathematician called John Wallis to obtain answers for a special class of definite integrals where for both limits given in the original question, this first term of this formula is going to be equal to 0. For example, let's say the two limits given to us are between 0 and pi over 2. In that case, if I use the upper limit pi over 2, we know cosine pi over 2 is equal to 0. Therefore, all of this term will be equal to 0 in that case. Let's look at the lower limit. The lower limit is equal to 0. When x is equal to 0, we know sine x term is going to be equal to 0. Thereby, all of this term will be equal to 0. Now for such limits, where for both upper and lower limits, this first term of this reduction formula is going to be equal to 0. We have a nicer reduced formula. That nicer reduced formula is I sub n equals n minus 1 over n times I sub n minus 2. This formula can be very effectively used to evaluate definite integrals of this form. However, we have to discuss this formula under two cases. First case is when n is odd. The second case is when n is even. During our last video, we discussed a complete example for the case where n is odd. In that case, we solved integration between 0 to pi over 2 sine 15th power x dx. The purpose of the video today is to discuss a complete example for the case where n is even. Today I'm planning to discuss the integration from 0 to pi over 2 sine 14th power x dx. If you revisit that reduction formula, I sub n being equal to negative 1 over n sine n minus first power x times cosine x plus n minus 1 over n times I sub n minus 2, we can see that for both of these limits, 0 and pi over 2, this first term is going to be equal to 0. Therefore, remember once again I sub n is equal to integral sine n power x dx. Now, if I have to integrate from 0 to pi over 2, we know the reduction formula reduces to a nicer form. I sub n equals n minus 1 over n times I sub n minus 2. Now, that's the formula I'm going to use to solve this example today. But I'm not going to straight away jump into n equals 14 case. I'm going to gradually derive a result that can be used for any even power. Then, in general, we will apply that for n equals 14 case. Alright, what's the smallest possible even number for n? Let's say n is equal to 0 as the smallest even number. In that case, my I sub n is equal to I0. I sub 0 can be more easily identified by looking at the original integration rather than the reduction formula. When I look at the original integration, I sub 0 should be equal to integration from 0 to pi over 2 sine 0th power x dx. Therefore, this is equal to integral from 0 to pi over 2 1 dx. This is equal to x from 0 to pi over 2, which reduces to pi over 2. Alright, now we need to keep in mind that I sub 0 is equal to pi over 2. We will use that result in the next step. Alright, now we will look at the next smallest even number, which is n equals 2. When n is equal to 2, I will have I sub 2. According to the new reduction formula right here, I sub 2 should be equal to, since n is equal to 2, n minus 1 over n will be 2 minus 1, which is 1, over 2 times I sub n minus 2, which is 2 minus 2, which is 0. We showed earlier that I sub 0 is equal to pi over 2. Therefore, I can write it down as 1/2 times pi over 2. Next, we will look at the next smallest even number, which is n equals 4. When n is equal to 4, I can write down that reduction formula I sub 4 is equal to n minus 1 over n. Since n is equal to 4, 4 minus 1 is a 3, and in the bottom I will have a 4 and I sub n minus 2. I sub 4 minus 2 is equal to 2. In the previous step, we showed that I sub 2 is equal to 1/2 times pi over 2. So we are going to use that result here. It will be therefore 3/4 times 1/2 times pi over 2. Alright, next we are going to look at the next smallest even number, which is n equals 6. By looking at this reduction formula again, we get I sub 6 is equal to n minus 1 over n with n equals 6 becomes 5 over 6 times I sub n minus 2 with n equals 6 becomes I sub 4. In the previous step, we showed I sub 4 is equal to all of these. So I'm going to use those for I sub 4 in this step. We have 5/6 times I sub 4, which is 3/4 times 1/2 times pi over 2. By this point, we can quite easily understand the sequence. However, we will do it one more time. When n is equal to 8, the reduction formula right here gives us I sub 8 equals n minus 1 over n with n equals 8 becomes 7 over 8, that times I sub n minus 2. With n equals 8, it becomes I sub 8 minus 2, which is 6. I sub 6 was calculated in the previous step, and that's equal to all of these. And therefore, this term becomes 7/8 times 5/6 times 3/4 times 1/2 times pi over 2. Alright, now quite easily the human mind can understand the sequence. If you look at I sub 8, we have 8 in the denominator right here and 8 minus 1, 7 on the numerator. And then if you look at the numerator, 7 minus 2 is a 5, 5 minus 2 is a 3, 3 minus 2 is a 1. If you look at the denominator, we have 8 minus 2 equals 6, 6 minus 2 equals 4, 4 minus 2 equals 2, and we have all of that multiplied by pi over 2. Even if you look at the previous one, that's also same. We have I sub 6, and that 6 went to the denominator. 6 minus 1, 5 can be found on the numerator. If you look at the numerator, 5 minus 2 is a 3, 3 minus 2 is a 1. If you look at the denominator, 6 minus 2 is a 4, 4 minus 2 is a 2. And finally, we have times pi over 2. Alright, now the life is easy. What if I have to write down the case for, let's say, n equals 12? N equals 12 will correspond to I sub 12. In that case, I need to write down 12 in the denominator. On the numerator, I need to write 12 minus 1, which is 11. And we can write down all the other terms quite easily. On the numerator, I will have 11 minus 2 equals 9, 9 minus 2 equals 7, 7 minus 2 equals 5, 5 minus 2 equals 3, and 3 minus 2 is equal to 1. In the denominator, 12 minus 2 equals 10, 10 minus 2 equals 8, 8 minus 2 equals 6, 6 minus 2 equals 4, and 4 minus 2 is equal to 2. Finally, I need to multiply all of that by pi over 2. Alright, now we can go back to our example. Our example is to evaluate the integral from 0 to pi over 2 sine 14th power x dx. In that case, we can observe that n is equal to 14. Therefore, we can now write down the final answer straight away. 14 will be in the denominator, and on the numerator, it will be 13. For the rest of the numerator, it will be 13 minus 2 equals 11, 11 minus 2 equals 9, 9 minus 2 equals 7, 7 minus 2 equals 5, 5 minus 2 equals 3, 3 minus 2 equals 1. For the denominator, we have 14 minus 2 equals 12, 12 minus 2 equals 10, 10 minus 2 equals 8, 8 minus 2 equals 6, 6 minus 2 equals 4, 4 minus 2 equals 2. And finally, all of these should be multiplied by pi over 2. Alright, now we need to simplify this answer and write down a nice final answer. When you simplify all of these, the final answer becomes 429 pi over 4096. Alright, I need to make a couple of comments. First comment. Remember, we started the reduction formula by writing the given integral sine nth power x dx as I sub n. And we used the reduction formula I sub n being equal to negative 1 over n times sine raised to the n minus first power x times cosine x plus n minus 1 over n times I sub n minus 2. Under the discussion for Wallis'S product, remember, we had this integral as a definite integral, which means we have certain lower and upper limits. Remember, before applying this theorem, we need to make sure that this first part of the reduction formula is going to be equal to 0 for each of those two given limits. The second comment is, remember, when you apply this equation, when this term is gone, you will need I sub 0. You need to always manually evaluate I sub 0 and use that value in the reduction formula. That I sub 0 may not necessarily be always equal to pi over 2, because that I sub 0 value depends on these given limits. Alright, those are the comments I have. Now, I would like to recommend you a homework question. So, if you would like to try that method for a homework question, here is my question. Integrate from 0 to pi sine 16th power x dx. Once again, please don't forget to evaluate I sub 0 manually for these two limits. Alright, that's it for the discussion today. I hope you enjoyed this video. Thank you so much.